So here we are, we're going to use our mathematics and mechanics skills to find the mass of this object. It might be easier to put it on the scales and actually work it out, but hey, we wouldn't be using any of our maths then. So here we go. There's the question, and we're given a diagram to start with the two forces as shown. But we need to complete this force diagram before we can start work. So what extra forces do we need? Well, it's a rough horizontal plane, so we're going to get friction, and friction is going to oppose the motion. The motion is clearly in that direction because that's the direction that both the forces are pointing in, so the friction is going to be in that direction. We've got the weight acting vertically down and the normal reaction from the surface. So there's our force diagram. And what should we do first? Well, I think that if we resolve perpendicular to the plane to start with, we can find the normal reaction, and that we can then use to find the friction. So that's the way I'm going to do it. So resolving perpendicular to the plane, these the friction has no component perpendicular to the plane. R and mg are both perpendicular to the plane. We've got the component of the 22 Newton force, which is 22 sine 39, and the component of the 15 Newton force, which is 15 sine 12. So taking account of their respective directions, we get R, which is upwards, 22 sine 39, which is upwards, and then the 15 sine 12 and the mg are both downwards, so they've got negative signs here. So that gives us an expression for the normal reaction. Now the particle is actually accelerating, the box is accelerating. So that means that the friction will be equal to F max, and F max is mu times R. So we know what R is, we know what mu is, so we can get an expression for the friction now. So there it is, mu 0.3 times the reaction there, which I got from here. And now we can resolve parallel to the plane. So that means that we don't need to take into account these two forces because they have no component parallel to the plane. We've got the component of the 22 Newton force parallel to the plane, which would be 22 cos 39, and the component of this force parallel to the plane, which will be 15 cos 12, and then we've got the friction, which is parallel to the plane. So 22 cos 39 is in the right-hand direction, as is the 15 cos 12, but the friction is in the opposite direction, so that's why we have the negative here. So resultant force equals mass, which I'm calling m, times acceleration, which we're given is 0.1 meters per second. So I can now substitute my expression for friction into there and get this long equation, multiplying out and moving the m term over. I get this, and that enables me to work out the mass, which is 11.5 kilos. So there we are. Not as easy as putting it on the scales, but perhaps more mathematical fun. Okay.